Hello and welcome. Today we're going to tackle a really fascinating topic: how scientists actually classify primates. It's a story about how science grows and changes, and it seriously shifts how we see our own spot in the animal kingdom. So let's just dive right in. In the previous video, we learned about the definition of primates. In this video, we will talk about the classification of primates. We're going to see how the methods themselves have evolved over time and what that really tells us about our own family tree. So to get started, you should know there isn't just one single way to classify life. For primates, we're really looking at two main systems. You've got the classic, original method, and then you have this modern upgrade that gives us a much clearer picture of our evolutionary past. Okay, so on one hand, you have classic taxonomy. This is the system you probably learned in school: kingdom, phylum, class, and so on. It basically groups animals based on physical similarities. But the upgrade is something called cladistics. Now, this method is way more precise. It's not just about looking alike, it's about being directly related. It focuses on shared, unique characteristics that show us direct evolutionary connections. To really get a handle on this powerful cladistic system, we need to get familiar with some of the lingo. Think of these as the tools scientists use to build those really accurate evolutionary family trees. First up is plesiomorphy. It sounds complicated, but it's really just a fancy word for a primitive trait. Think of it as an ancient feature that's been passed down from a very distant ancestor. A perfect example is having 5 fingers and 5 toes. Primates have it, sure, but so did the early amphibians and reptiles they evolved from. It's a shared, really old characteristic. On the flip side, you've got apomorphy, which is a derived trait. Now, this is a new feature, an evolutionary innovation that separates a group from its ancestors. For primates, a classic example is having nails instead of claws. That's a new development that set us on a completely different path. And apomorphies come in 2 important flavors. First, there's an automorphy, which is a unique derived trait that you only find in one specific group, like the fact that apes don't have tails. Then there's a synapomorphy, and this is a shared derived trait that links a few groups together. A huge example here is bipedalism, walking on 2 legs, which is the absolute key trait that defines our specific evolutionary tribe, the hominins. Now here's a crucial curveball: homoplasty. This is what happens when a similar trait evolves completely independently in different groups. A great example of this is arm swinging, or brachiation. Some monkeys can do it, and apes can do it, but they didn't get it from a common arm-swinging ancestor. They developed it separately. This is a classic case of convergent evolution, and cladistics is the tool that helps scientists spot these tricky, false connections. All right, with that vocabulary down, let's actually apply these tools to the primate family tree. The very first big split in the primate order creates 2 fundamental branches, and they really highlight the difference between the more primitive and the more modern primates. This table shows that split perfectly. You've got the strepsirrhines, who hang on to primitive traits like a wet nose, which means they rely a whole lot on their sense of smell. And then you have the haplorhines. That's the group that includes monkeys, apes, and us. We have simple, dry noses, and we depend way more on our vision than on smell. And now we get to the most dramatic part of this story. Applying these cladistic ideas, especially when you add in the power of modern genetics, has completely revolutionized how we classify the great apes. It has profoundly changed our understanding of our own family. Here's the absolute heart of the matter. The old system put humans in our own exclusive family, Hominidae, completely separate from all the other apes. But the new system, which is backed by just overwhelming genetic evidence, changes everything. The family Hominidae now includes all of the great apes. We're not in some separate club anymore. We're just part of the family. So let's walk through this new hierarchy. At the very top, you have the family Hominidae, which is all the great apes. Then, if we zoom in, you get the subfamily Hominini, which groups together just the African apes. That's gorillas, chimps, and humans. Then, at the tribe level, the gorillas branch off on their own, and that leaves just us and chimps together in the tribe Hominini. It just goes to show how incredibly close our evolutionary relationship really is. And this brings us to a super important definition. The term hominin refers specifically to this final branch, our tribe, homini. It includes us, modern humans, and all of our extinct relatives who showed up after our lineage split from the chimpanzee lineage. Okay, let's put it all together and do a direct comparison of our place in the family tree. The old way versus the new, much more accurate system. Here it is, the key takeaway. The old system, on the left, gave us our own private family, separating us from the other apes. Back then, hominid just meant human. But now, look at the new system on the right. It places us squarely inside the great ape family. Now, hominid refers to all great apes, and the much more precise term for our unique lineage is hominin. In the next video, we will learn about great apes. By the way, human beings are great apes.